Hi everybody, this is Miss Bufford and this video is going to cover building block 4 in our solutions unit. Building block 4 talks about solubility curves and solution saturation. And your learning goals for this building block are to be able to define and describe how to make unsaturated, saturated, and supersaturated solutions. And you should be able to read and understand a solubility curve. All right, so this is a solubility curve here, and it's important for me to point this out to some people because some people have never really thought about this before, but there's actually a limit to the amount of solute that water can dissolve. So it's not going to continuously, endlessly dissolve everything you put in it. So there is a maximum amount of solute that you can dissolve for every unit of volume for water. So the solubility curve is a graphical representation of the amount of solute that can be dissolved in 100 grams of water at a given temperature. So if you take a look at the graph, temperature is listed along the bottom and it increases from left to right. And from bottom to top is an increasing amount of solute. Okay, so that's the amount of solute in grams along the vertical axis. Okay, so each line, each colored line in this graph represents the maximum amount of each solute that we can dissolve in 100 grams of water at each temperature. So if you take a look at these right here, what do we notice about most of these substances as temperature increases? And if you need a minute to think about it, go ahead and pause the video. Thinking through stuff like this yourself is good to do. And if you pause the video, what I hope you notice is that most of these substances, their solubilities increase as we increase temperature. And so that kind of shows you that, for water, its capacity to hold more solute increases as temperature increases. All right, so we can use the terms unsaturated, saturated, and supersaturated to describe solutions. And a point that falls directly on one of these lines on this graph is going to represent a saturated solution. And a saturated solution contains the maximum amount of solute that can be held by water at that temperature. So if we're gonna use sodium chloride, it's that bright blue line right through the middle of the graph. That's going to be our example for all of these here today, at least for this slide. So let's say I'm at 90 degrees. I have water at 90 degrees, and I want to know what is the maximum amount of solute that I'm going to be able to get to dissolve. So if I go to 90 degrees and I go all the way up to that light blue line in the middle, then I can see that I'm going to be able to dissolve exactly 40 grams of salt, of sodium chloride, in that water at 90 degrees, right? And I won't be able to get any more to dissolve. All right, so a point below the saturation line, so we'll think of all these colored lines as saturation lines. A point that falls below that line for a particular substance is going to represent an unsaturated solution, meaning we can add more solute to that and get more solute to dissolve. There's room for more in an unsaturated solution. And then a point, we'll give you an example for that. So we'll take a look at sodium chloride again, and we're still at 90 degrees. And let's say I have a solution that only has 20 grams of salt dissolved in it, then that would be an unsaturated solution because I could potentially add another 20 grams. There's room for 20 more. Okay, and a point above the saturation line, so let's say I'm at 90 degrees for sodium chloride again, and let's say I somehow have managed to get 50 grams of sodium chloride to dissolve at 90, and the solution is at 90 degrees. That would be considered a supersaturated solution because I have more solute dissolved in that solution than I would normally be allowed to dissolve, all right, than normally we could get under normal conditions to dissolve. And so before we move on, we're going to do some practice reading a solubility curve And then we'll go through unsaturated, saturated, and supersaturated solutions and talk a little bit more about each one. So problem number 1 says how much potassium chloride can dissolve in 100 grams of water at 60 degrees Celsius. So potassium chloride, I need to find that line on my chart. And so take a look around and hopefully you can see potassium chloride. It's that dark blue line across the middle, KCl. And that line represents our saturated solution concentration. And so I want to know at 60 degrees Celsius how much potassium chloride could I get to dissolve in that solution. So I'm going to go down and find 60 degrees Celsius, and then I'm going to follow that line straight up until I touch the line for potassium chloride. And if I look right across, that's about 45 grams. So it's safe to say that I could dissolve about 45 grams of potassium chloride in 100 grams of water at 60 degrees Celsius. So the answer there is 45. And I'm sorry, I can't annotate on PowerPoint with the Mac, so go ahead and write that in your notes if you're following along. All right, so question number 2 says how much calcium chloride can 100 grams hold at 20 degrees Celsius, 100 grams of water. So I'm going to find calcium chloride, CaCl2, and it's the orange line kind of up in the upper left-hand corner. Everybody see it? CaCl2. And it says how much can it hold, or how much, let's see. So 20 degrees Celsius, I'm going to find that down here. And then I'm going to follow that line straight up until I hit the orange line for calcium chloride. And that looks like it's about 75 grams of calcium chloride that I could get to dissolve at 20 degrees Celsius. So the answer for number 2 would be 75 grams. Number 3 says which compound has a solubility that decreases as temperature increases. So there is one seemingly outlier on this table. Most of these substances, their solubilities increase as we increase the temperature, but there is one down here at the bottom, cesium sulfate, that actually has a solubility that decreases and then kind of levels out as we increase temperature. So cesium sulfate would be the answer for number 3. Number 4 says which compound has the greatest solubility at 10 degrees Celsius. So we're looking for the one that we can dissolve the most of. So which one is going to be highest up on that chart? So I'm just going to go find 10 degrees Celsius, and I'm just going to follow it all the way up until I hit the highest line, which happens to be for sodium nitrate, NaNO3. That's going to have the greatest solubility at 10 degrees Celsius. So your answer here would be NaNO3. And the last one, number 5, says if 100 grams of water contains 10 grams of potassium chlorate at 30 degrees Celsius, what is the saturation of the solution? So I want to know if it's unsaturated, saturated, or supersaturated. So I first need to find potassium chlorate on this chart. So here it is, it's that brown line. If you can find the brown line, KClO3. And then I need to find 30 degrees Celsius. And if I am at 30 degrees Celsius and I go up to 10 grams, because it says I have 10 grams of that dissolved in there, I actually fall right on that line. And so that means that I have a saturated solution. Okay? So the answer to number 5 is saturated solution. If you are struggling to figure out where I'm getting these answers from, or you're not sure and you have questions, just go ahead. If you're one of my students, go ahead and email me, and I'm happy to answer those questions for you. All right, so let's talk a little bit about the unsaturated solutions for just a minute. So there's some different ways that you can recognize this, or recognize an unsaturated solution. If you know how much water you have and you know how much solute is dissolved in that water, then you can consult a solubility curve to determine the saturation level of that solution. So If you fall below that line that represents the point of saturation, then you know your solution is unsaturated and you can dissolve more solute in there if you wanted to. If you don't know the amount of water and you don't know the amount of solute that you have that you're starting out with, and you need to figure out whether it's unsaturated, saturated, or saturated, then you could add a little bit more solute and stir it. You want to give it a good stir. And if it dissolves, then that means you had an unsaturated solution. And the way to make an unsaturated solution would just be to take some water and add an amount of solute that's less than the maximum and stir it until it's dissolved, and then you have yourself an unsaturated solution. Saturated solutions. So you can recognize a saturated solution in a couple different ways. The first one, again, if you know how much water and solute you have, then you can use a solubility curve to determine that solution saturation. If you don't know the amount of water or the amount of solute that's already been dissolved, you can always add a little bit more solute and dissolve it. And if you end up with some particles at the bottom of that container that you can't get to dissolve, let's say you put a little bit more solute in there and you just can't, you've stirred it and stirred it and stirred it as much as you can and you just can't get it to dissolve, then that's probably a saturated solution and it's not going to dissolve anything else. And so the way to make a saturated solution is you're going to add an amount of solute and you're going to stir it until it dissolves, and you're going to keep adding solute until you get to that point where you can't get anything further to dissolve. And you'll usually have solute floating around at the bottom that's just, it's not going to dissolve. All right, now supersaturated solutions. If you, again, to be able to recognize these, if you know how much water and solute you have, and you can consult a solubility curve, and you notice that the point where the water and the amount of substance you have is above your saturation line for that particular solute, then you know your solution is going to be supersaturated. However, if you don't know if the solution is unsaturated, saturated, or supersaturated, you can add a little bit of solute, do a little experiment. And in this case, if you add more solute, then if your solution is supersaturated, what you're doing is you're introducing like a matrix that those ions or those molecules that are dissolved in that water can recognize. And what they're going to start doing is they're going to start precipitating out of solution and crystallizing. So you're actually going to see a crystallization reaction occur. And this is how they make rock candy. They make supersaturated solutions of sugar water, and they grow the sugar crystals on some surface that they put in there. Sometimes it's a string or a wooden stick or something like that, depending on, or maybe even just little pieces of sugar. When this happens, and the amount of solute that crystallizes out of solution is going to leave the solution behind as a saturated solution. So you're only going to be able to get out as much, like a mass that's equal to the excess solute that's in there above the saturation point. And to make a saturated solution, we have to add a bunch of solute into water. Usually we have more solute than water in a supersaturated solution. And in order to get it to dissolve, we have to raise the temperature. So we have to dissolve a bunch of solute, raise the temperature, add some more solute, keep dissolving it, and raise the temperature to the point to where you have no solute left. You want to stir it and keep it hot. And once everything has dissolved, you're going to remove it from heat and let it very slowly cool down. And it's important to note too that it's not going to be considered a supersaturated solution until the temperature falls back down below that's the new saturation point. Because remember, water can hold more solute at higher temperatures. And so at that higher temperature, if you leave it at that high temperature, it's still a saturated solution. But as you let it cool down, water's capability or capacity to dissolve that much lowers. And so now you have a situation where the solution is very unstable. And if you were to introduce some surface where crystals could begin to grow off of, then you're going to have all of that extra solute recrystallizing out of your solution. And so this is a really cool video that you can watch for fun. He actually does several different fun things with a supersaturated solution, and I don't want to spoil it. So if you have the PowerPoint, should be linked in It's Learning, so you should be able to pull up that PowerPoint and get to this video from YouTube. Okay, so let's say that each cup below holds 100 grams. Each one of these cups, A, B, C, D, and E, has 100 grams of water, which is also equal to 100 milliliters of water. They're the same. And it has some solute in it. We don't know what the solute is, but we know that the maximum amount of this solute that can be dissolved in 100 grams of water is 8 grams of the solute. Okay, so we can only get 8 grams of this solute to dissolve for every 100 grams of water. So we need to use that information to describe the solutions below using the terms unsaturated, saturated, or supersaturated. So I would like for you to pause the video for just a minute and see if you can figure out which one of these are going to be unsaturated, saturated, and supersaturated. And then we're going to go ahead and talk about it right now. Okay, so cup A. We know that we could potentially have 8 grams of our solute dissolved in here, but we only have 2 grams. So we could potentially add 6 more grams to this before we reach our saturation point. So A is going to be an unsaturated solution. B has 4 grams of the solute dissolved in it, but again, we could potentially have 8 grams, and so we could fit 4 more grams in here. And so this is also going to be an unsaturated solution. And then cup C has 6 grams of this solute dissolved in it. And again, we could fit up to 8 grams, so we could potentially dissolve 2 more grams in here. So C is also an unsaturated solution. And D has 8 grams dissolved in it, and that's the maximum amount. We can't fit any more solute into that solution, so D is going to be our saturated solution. And E is going to be our supersaturated solution because we've got 10 grams dissolved in there when we could really only dissolve 8 grams. And so we must have heated this cup up to get the rest of that solute to dissolve and then let it cool back down to the same temperature as the other ones. And now it's supersaturated because nothing has crystallized out. It's all still in solution. Okay. And this is the last slide. If you want a quick refresher, this video is shorter than my video was. And she explains it pretty well. So if you want a quick refresher later on, this is available in the PowerPoint that goes with this slideshow for you to get a quick recap. Thanks for watching.